Okay, in this video, we're going to use the law of sines, which is trigonometry, to find angles or sides of a triangle. What's really nice with the law of sines is that we can use this with any triangle. I know we've been working with right triangles previously, but you can use this with a right triangle or any other type of triangle. Remember with our triangles that for the angles, we use capital letters. And if we call this A, B, and C, it's really important to know which side goes with those angles. So if this is angle A, the side opposite it is side A, and we use a lowercase letter. If this is angle B, this is side B, and if this is angle C, this is side C. Now, we could also call this side AC. We could talk about the length of AC, or we could call this side BC or CB, and we could actually call this side AB. So you might see it in a couple different ways, but know that if you're asked for little a, then we're referring to this side, but that if you're asked for BC, that's the same side in this triangle. Okay, here's our formula. Notice that all of these are lowercase letters, which are our sides, our side lengths, okay? And then all of these are uppercase letters, so this is going to be the sine of the corresponding angle. And you do have to do the sine of that on the bottom. So the sine is on the bottom and the sides are on the right, and you only have to use two of these. So for example, if I know information about A and B, I would use this part, okay? Or if I knew information about side B and angle B and then something about C, I might use just these two, or I could actually use this one and this one. So this is just a rough formula to make sure that you know which angle goes with which side, but you can use any combination. Side is always on the top, sine is on the bottom, and they have to be corresponding. So side A, sine of angle A. Side B, sine of angle B. Side C, sine of angle C. Okay, so now we're going to look at an example. On example 1, we're actually asked to find the length of AC, which is going to be this side is what we're trying to find. Notice that I actually have angle A and side lowercase a or side CB. So what I'm going to do is I'm going to use these two are corresponding. This is the angle and this is the side that's opposite it. So I'm going to say 34 over the sine of 108 degrees, because based on our formula, these two go together, is equal to, now I have angle B and I want to find this side, which we could call side B, or we could call side AC like they did here. Okay, so those are opposite, so that's good. So we're going to put B, or side AC, either way, and the sine of 49 degrees. So now we need to solve that. The way you solve, the easiest way is we're going to cross multiply. So I'm going to do 34 times sine of 49 degrees, which is going to look like this. And I'm going to do side AC, if that's what I called it, times the sine of 108 degrees. Now remember, this is what I want to solve for. So I'm just going to go ahead and divide over here by everything that isn't side AC. So I'm going to divide by sine of 108 degrees. On both sides, this one cancels out, so I get that the length of AC, or side AC, is equal to all of this, which I can actually type in my calculator very carefully, 34 times sine of 49 degrees, and then divide by sine of 108 degrees. And when I do that, I get 26.98. If we were rounding to the nearest tenth, if that was in the directions on your assignment, which it often is, we would get 27.0, because this 8 would cause this 9 to go up, which would actually cause that to go up. So this would be my answer. Or this, if you were asked to round to the nearest hundredth. Okay, why don't you take a minute and try problem 2. Okay, on number 2, we're asked to find side AB, or the length of AB, which is this here. So if I want to find this side, I need the angle opposite it. So I'm going to say side of AB over the sine of the angle that's opposite is equal to, now I have this one, I have this angle B, and I have side lowercase b, or the side opposite it. So that works well. So I'm going to have 31. Remember, sides always go on the top, and the sine of the given angle always goes on the bottom. So this is my setup. So now when I cross multiply, I'm going to do 31 times sine of 25, and I'm just going to write that. I'm not going to solve anything yet. Is equal to, and then I'm going to cross multiply there, and I'm going to get AB sine of 139 degrees. AB is what I want. I want to solve for that. So I'm going to divide by everything that's not AB. So sine of 139 degrees. That's going to cancel, but I'm going to divide it over here as well. And I'm going to do that math in my calculator. So I'm going to get that AC is equal to all of this typed in very carefully, which is actually going to come out to 19.97 if I round to the nearest hundredth, or actually it's actually 19.969, which would be 20.0 if I rounded to the nearest tenth. Okay, the nice thing about this is we can also use it to find angles. So on number 3, we're asked to find the measure of angle A. So we want this, which we may call theta, or you could call it angle A, it doesn't matter. So I have this angle and I have the side that's opposite. So I'm going to say 14, which is the side, over sine of the angle. Now you can put theta here, or you can put angle A, as long as you remember that with theta we're talking about angle A, is equal to, now look at what you have. You have angle B and you have the side across from it, so you're set. We're going to put the side on top, and we're going to put sine of 89 degrees on the bottom. And now we're going to solve. So we're going to cross multiply here. We're going to get 14 sine of 89 degrees. And then we're going to cross multiply here. We're going to get 32 times the sine of theta. Now, I want to solve for theta, so I want the sine of theta by itself. I'm going to divide by 32. And what I have so far is the sine of theta on this side, which is equal to what we get when we do this math in our calculator carefully. And when we do that, we actually get 0.43743, and then there's some other digits here. But remember, we learned this last time in our last lesson. We want to solve for theta. So to get theta, we actually do sine inverse of both sides, which cancels on one side. And we're going to type this in our calculator. So we would get theta, or angle A in this case, is going to be equal to 25.9. So I could say that the measure of angle A is 25.9. Okay, why don't you take a minute and try number 4. Okay, on this problem, again, we're asked for an angle. So I'm looking for this angle right here. And I have the side that's opposite. So I'm going to put the side on top, and on the bottom I'm going to put sine of, well, let's use B in this time. Sine of angle B is equal to, now, I have this angle and I have the side across from it, so I'm good. If I had this angle and this side across from it, then I would have used those. But they set it up nicely for me. So I'm going to have the side length on the top and the sine of 65 degrees on the bottom. Okay, and now I need to solve. So cross multiply gives me 10 times sine of 65 degrees. Cross multiply here gives me 35 times the sine of B. Again, I want to find B, but I got to get sine of B by itself first. So I'm going to divide by 35. And I'm going to do all this math in my calculator. That's going to give me the sine of B is actually equal to 0.258945 and a few other digits. But remember that I'm actually taking the sine inverse of both sides. So the sine and inverse sine of all of this. These two cancel, and I get that B, angle B, is equal to what I get when I do this in my calculator, which is going to be 15.0. So the measure of angle B is equal to 15.0.